Hey good people, Arthur Morris here. I hope all is well. In this video we're going to look at the basic differentiation rules and rates of change. The first rule we're going to look at is the constant rule. It says the derivative of a constant function is 0. So this d over d of x, with respect to dx of c equals 0, that says that the derivative. This can also be written as f prime of x. You may see f prime of x as a notation for a derivative. If it's in the y form, you may see y prime as well. Alright, so the derivative with respect to x for the power rule, derivative with respect to x of x to the nth power, what you would do, you would bring the exponent out in front as a constant, and then you would subtract 1 from the exponent. Alright, the constant multiple rule says if f is differentiable, it's a differentiable function. So if we have a constant being multiplied times a function and we want to find our derivative, we first find the derivative of the function and then multiply it times the constant. So if you need to write those down, you may want to pause the video here and write those 3 down. Okay. Alright, the next 3 we're going to look at or the first one is the sum and difference rules. It says if we are finding the derivative of the sum or difference of functions, then we would first find the derivative of each function and then add those results together, or subtract if we're using the difference. And the last theorem here that we have is the derivatives of sine and cosine functions. The derivative with respect to x of sine of x equals cosine of x, and the derivative with respect to x of cosine of x equals negative sine of x. Okay, so let's look at some examples here. Alright, so this first one we have y equals 12. We want to find the derivative. The derivative of a constant is equal to 0. So think about drawing this out and remember the derivative is rate of change or slope, and the slope of any horizontal line is 0. Okay, number 9, we have the 5th root of x. F of x equals the 5th root of x. The first thing that we would need to do is to rewrite this in exponential form. So f of x equals x to the 1/5 power. And then we would use our power rule. And the power rule says that we take this exponent, bring it down as a coefficient, and then subtract 1 from the exponent. So we bring that down as a coefficient and we subtract 1 from that exponent. In this case, subtracting 1 would be the same thing as subtracting 5 over 5. Alright, and I normally don't leave negative exponents, and the computer may allow it, but I normally don't leave negative exponents. So f prime of x is 1 over 5 times x to the positive 4/5 power. Alrighty, number 12, we have g of x equals 6 times x plus 3. So we want to find the derivative of 6x and the derivative of 3. Alright, so the derivative of 6x, we have an understood 1 as an exponent, so we're going to use our power rule there. So we have 1 times 6, and we subtract 1 from the exponent, so that's x to the 0 power. And then the derivative of 3, our derivative of any constant, is 0. So we find the derivative of each one of those terms. Alright, so let's simplify that now. So 6 times 1 is 6. X to the 0 power is 1. Any exponent to the 0 power is 1. So g prime of x simply equals 6. Alright. Alrighty, number 17 here we have s of t equals t to the third power plus 5t squared minus 3t plus 8. So again, all you need to do is to find your derivative of each one of those, and we're going to use the power rule on those first three terms, and then on the last term we're going to use the constant rule. So s prime of t, this first one, 3t or t to the third, multiply by the exponent and then subtract 1, so 3 times t squared. And you could use the limit process for all of these, but make these problems a lot longer, so make sure you learn your rules. So this right here is basically a shortcut for what we did in the previous lesson. Alright, so 2 times 5 is 10. Subtract 1 from the exponent makes t to the first power. Then understood exponent of 1, so negative 3 times 1 is negative 3. T to the 0, so we won't have t anymore. And then derivative of a constant is 0. So we have s prime of t equals 3t to the second plus 10t minus 3. Alrighty, now we have y equals pi over 2 sine of theta minus cosine of theta. So that pi over 2, that's just a regular number, so it's just a constant there, so we don't have to worry about that. Remember to find the derivative of a constant multiple. All you want to do is to find the derivative of the function and then multiply times that constant that's out there. So the only thing that we need to do here, the first thing we need to do is to find the derivative of sine theta. And if you go back to the notes, the derivative of sine is cosine. So y prime equals pi over 2 times cosine of theta minus, and then your derivative of cosine of theta is negative sine. So I just found the derivative of each one of those, and now just simplify it, clean it up some. So cosine of theta and then plus sine of theta. And that should be theta up there, sorry about that. Alrighty, next up we have rewriting a function before differentiating. Complete the table. So you have to complete this table. So they want us to complete this table by rewriting the function. So you have a few parts here. Alright, so y equals 5 over 2x squared. So let's rewrite that. And make that, I'm going to write it underneath these gray boxes. Let's rewrite that as 5 over 2, or 5 over 2 times x to the negative second. Now that allows us to use the product rule. So now we can multiply. So differentiate, we're going to multiply by negative 2, and if we multiply by negative 2, that will give us the 2 and 2 will cancel, we'll keep the negative, so that will give us negative 5, and then subtract 1 from the exponent to the negative third power. And let's see here, so let's write this step out. Negative 5x to the negative third, and then simplify, so negative 5 over x to the third power. Alright, so number 30, rewrite it. So 4 times x to the third power. Differentiate, so 3 times 4 is 12. Subtract 1 from the 3 is 2. And then simplify, it's already simplified, so we would write the same thing. Okay. All right, let's look at finding the derivative of these functions. Okay. This first one, we have g of t equals t squared minus 4 over t to the third. All right, so let's rewrite the second term there. So we have t squared minus 4 times t to the negative third. All right, now we want to differentiate each one of those terms. So g prime of t is 2 times t, subtract 1 from the exponent. And then you have negative 3 times negative 4, so that's going to make positive 12. And if I subtract 1 from that exponent, that's going to make t to the negative fourth. Going to give us t to the negative fourth. Okay, and then let's clean that up a little bit. So g prime of t equals 2t plus 12 over t to the fourth. All right, number 43. F of x equals 4x to the third plus 3x squared, all divided by x. I would say, first of all, simplify, because since all of those have x's, and you can do this a couple of different ways. I'm just going to factor out an x. And that allows me to cancel those x's there. And then I will find the derivative of those two functions. So multiply 2 times 4 is 8. Subtract 1 from the exponent. Understood exponent of 1 here. 1 times 3 is 3. So f prime of x equals 8x plus 3. Alrighty, let's look at one more example. So on this one we have f of t equals t to the 2/3 minus t to the 1/3 plus 4. So again, we just want to use our product rule here. Be careful with those exponents in your subtraction. All right, so t to the 2/3, that will give us 2/3 times t. And then we have to subtract 3/3. So that will give us negative 1/3 minus 1/3 t. Again, subtract 3/3. That will give us negative 2/3. And then remember, the derivative of a constant is 0. So the derivative of 4 would be 0. And then, again, the computer may accept it this way. If so, that's fine. I'm going to make my exponents positive. And that's it. And when I said the computer may accept it this way, you definitely wouldn't want to have the plus 0 there. So it may accept with the negative exponents, but you would not want to put the plus 0 in your answer. Alrighty, good people. I hope you found this video to be helpful, and I will see you on the next one. Thank you.